Press record. Okay.
There we go.
Now we're going. All right, so now we got Oliver. Shallow. Oh, we got the proposed one. Okay. We did the price elasticity of demand. So that dealt strictly with the demand curve. And as you'll find if you've done your reading, or you will find out eventually, there's a whole bunch of elasticities. So the concept of elasticity can be applied to a number of different variables that are important in consumer decisions. So in chapter 3, we talked about things that shift the demand curve, stuff like income, price of substitutes, price of complements, right? Different things will also alter people's consumption behaviors. And so we're going to build elasticities for those things too. And so this will be kind of a review for this because you end up applying the same concept each time. So I think what I'll start us off with maybe sticking with the theme of demand, I guess we'll jump right into the income elasticity. So the income elasticity, which I'll define here in a moment, but let's do the formula since I got the formula stacked up here. It's the percentage change in quantity demanded that comes about from a percentage change in your income. You can see how similar the formulas are. It's really the same type of thing. Income goes up by 10%. How many more iPods do I buy? Right? Do I buy 20% more or do I buy 1% more? Or do my purchases actually fall as my income goes up? Which we saw some of those cases in the shifter stuff. As income goes up, quantities demanded falls for what types of goods? Inferior goods. So non-normal goods, right? We had normal goods and inferior goods. So now that's going to play itself out a little differently here with the income elasticity. Let me put a formula then. The income elasticity is a unitless number. I'll add that word unitless. We learned that last time. A unitless number that shows the responsiveness of quantity demanded to a given change in income.
So are you using responsiveness and elasticity interchangeably?
I don't want to define what an income elasticity is by putting the word elasticity in the formula, but yes, I think if I'm understanding right. So the responsiveness is kind of how springy are you, how responsive quantity demanded is. That's our variable that we're keeping an eye on. How much does that change in response to income? How much does that change in response to price, right? So the elasticity of the quantity demanded to changes in things. Okay, so let's see here. Let's do a little example. So let's suppose that the income elasticity for beer is 0.93 and income increases by 7%. How will the quantity demanded of beer change? Now I approach this one a little bit differently, giving you the elasticity and some income information. What do we need to do with this problem?
rearrange the equation.
Good. Rearrange the equation. This equation, we've got this, solve for this. Go. Do it. What do we get?
6.51.
6.51. Okay, 6.51% or 651% or 0.0651% or 0.0651.
651.
Final answer is 651. 6.51%. Okay, now how do you know that? How can you kind of do a gut check on this? Of, let's say you get kind of confused because you put in what's my percent here? 0.07. If you would have used 0.07 and you kind of confused, oh, I get this number. How can I double check that I've got the decimal place in the right spot? What's a good double check after you get your answer? Move it over 2 spaces. That's not going to help me double check, though, afterwards. So you're sitting here with your calculators. Most of your calculators don't have, where's my eraser here? Don't have the little percent sign. So you're sitting there kind of confused. Do I need to slide it over to the 651? Do I keep it there? I'm not sure what to do. How should you handle it?
Should it be like relatively close to the change in?
Yeah, that's kind of what
That's
I thought.
kind of a gut feeling. You're on the right track, but no, not necessarily. It could be really responsive. So there could be a 200% percentage change due to a 10% increase or something. They could be far apart, if I understood your comment right. But you're on the right track.
You just like kind of look and see what that equals. What
Okay.
we're solving for when we're solving for percent change quantity demand.
Okay.
So that's like 6.51 equals percent change quantity demand.
All right. Yes, you could try to track back. I think I got a better one for you, Austin. Plug it back into the formula. Which one?
The elasticity.
The original one, I think, is the best one to do. Yes. So if you plug that back in here, now it starts to make sense. If you take your answer of 6.51 and put it over what was given to you in the problem, a 7, that number needs to equal 0.93. And see, if you would have put in the 651, it would have not matched. So that's a good double check, is to take your answer and just check it back to the original formula to see if that number makes sense. Because it is possible, maybe some of you did it. Did any of you put in 0.07 instead of using 7%? Yeah. So that's not uncommon. So then you got 0.06 down here, right? And then you had to see, well, what is that? Is that 0.06% or is that 0.06 as a number? So those of you who did that, to change it into a percent, would need to shift it over 2 spots. But at least you know you got the right number. Okay, any questions there? All right, so is beer a normal good or inferior good in this problem? Is beer a normal good or inferior good in this problem?
Normal.
Normal. Why?
Because the demand increases.
Because the demand increases. The two work together. Now, from a mathematical standpoint, how did that reveal itself from the numbers that you generated as far as the value of the income elasticity? What sign was it? It was positive. So we don't write this positive typically, right? But that positive told you the story that as income goes up, people buy more of it. So this one going up, they both move together, that's a positive sign. If we would have been talking about Keystone Light, then possibly an increase in income causes a decrease in the quantity of purchases of Keystone because it's an inferior good. If that's the case, then maybe the Keystone Light income elasticity for the Keystone here would have been equal to, I don't know, 0.46 negative. So the sign of the elasticity matters when it comes to calculating this one. With price elasticity, the first one we did, the sign was always negative. So we talked about it as a positive, just to screw up students, right? So we took that absolute value, like when we verbalize it, we'll a lot of times just say, oh, the elasticity is equal to 1.2, you know, because you already know that there's a negative relationship due to the law of demand. All right, so let's interpret this here. Well, wait, let me summarize the sign business though. So one of the key points here with income elasticity. If the income elasticity number is greater than 0, i.e. it's positive, like we did in this example, if the income elasticity is greater than 0, a positive number, then the good is normal, a normal good. Tying it back to chapter 3. If the income elasticity is less than 0, then the good is inferior, an inferior good. And then again, we like to always kind of theoretically cover all our bases. What happens if it's equal to 0? What would that tell you about income and the quantity of purchases with this good? There's no change, right?
It could be 0 if there was no change in quantity demand.
That's right. That's how it would come out in the numbers. What's it telling you about in real life between this good, whatever it is, if it's beer and income? What's the relationship? What's the story being told, the real world story? How are income and that good related to each other? They're unrelated, right? They're not related to each other. They're not positively related. They're not negatively related. It's like, it's kind of independent of income. There's no real statistical relationship there between income and the quantities purchased. So if we get an income elasticity of 0, then income and purchases are unrelated to each other. So I know some of you have had some of the basic statistics course. I know some of you haven't. So when we start doing a real-world analysis, we likely won't get it right on the money 0. We'll get something like 0.003. And then we'll do some statistical tests to say, is that close enough to 0 to call it 0? So if that number is significant or not. And so that's how economists go about testing these values to see if they really have meaning or not after we calculate it. We can kind of say, all right, that one's close enough to 0 to call it 0. Income and the quantity of purchases aren't related to each other. All right. Questions on that one at all? Yes?
Well, it's not related to elasticity of income, but elasticity of demand, so. Well, it says elasticity of demand is always negative due to the law of demand.
Yes. So on the elasticity of demand formula, if we think about the direction that they're heading, if we increase price, what happens to the quantity people are buying? It goes down. So they move in opposite directions. Same thing if there's a decrease in price, people buy more. If things get cheaper, people buy more. So those two variables are always moving in opposite directions. And so when we calculate a 10% increase, that's a positive number, it leads to a negative thing happening up here. And so then the negative number comes out. So the elasticity of demand is always negative. And then again, to confuse students, we often will speak about it in terms of its absolute value. Okay? All right, we're going to do a little bit more here too. I wanted to do one last thing with this, and that is to give an interpretation. How do we interpret the income elasticity? Interpret the income elasticity of 0.93. So, what's the trick? I guess before I give it to you here, before I spoon feed you. No, it's not related to the double graph. It's kind of back to the trick we can do with, here's the income elasticity, here's the formula. All we've got is a number, and we need to interpret that number. What did we do to that number to help us kind of tell the story? There's one simple little thing you can always do with any number to turn it into a fraction. Put it over 1. So if we put that over 1, and now look back to your formula, a 1% increase in income leads to a 0.93% increase in quantity demanded. A 1% increase in income leads to a 0.93% increase. Notice not 93%, right? So we're putting that fraction 0.93% increase, because it's a positive number, in quantity sold. Or let's just put quantity demanded this time, but I'll put parentheses sold. I think I flipped those around. But sometimes your text will say, kind of go back and forth between those. So again, this whole 1% business is kind of following that number. This thing is following that number. It gives you a nice way to interpret that number. Put it into words that the CEO can understand when you come back with your econ gibberish of elasticities. All right, next one, the cross-price elasticity. Cross-price elasticity, which I'm just going to put the sigma or a big E, you can use a capital letter E, whatever, CP for cross-price elasticity. And it is a unitless number. A unitless number that shows the responsiveness, you see a little pattern going on here? The responsiveness of quantity demanded from a change in the price of a related good. A unitless number that shows the responsiveness of quantity demanded from a change in the price of a related good. Formula. The cross-price elasticity equals the percentage change in quantity demanded divided by the percentage change in the price of a related good. All right, so get rid of this stuff here. So let's see, let's stick with our beer theme here. Suppose there's a decrease in the price of beer of 10%, and sales of wine increase 12%. So there's a decrease in the price of beer. Suppose there's a decrease in the price of beer of 10% and an increase in sales of wine by 12%. Calculate the cross price elasticity of beer.
Thank you.
All right, so plug and chug. Here's your formula. And actually, I wanted to do wine, sorry. I'm not trying to pull a fast one on you. So, quantity of wine sales, sales of wine by 12%, price of beer changed 10%. Answer?
1.2.
1.2. Okay. 1.2. So the cross price elasticity of wine equals the percentage change in the quantity of wine divided by the percentage change in the price of beer. Those numbers were fed to you up here. You just had to get the right one on top. So we had a 12% and a 10%, giving a 1.2. Ah, negative why?
Because the price of beer went down,
Okay.
while the quantity of wine went up. So there's a negative relationship.
All right. So we had a decrease of price, which would be reflected in a negative 10. Good. Which gives us an overall negative 1.2. How would you interpret the relationship between beer and wine? Are they substitutes or complements? Substitutes. Let's see. We try to remember back to chapter 3, lists that you've got memorized of shifters, right? An increase in the price of Pepsi leads to increase or decrease in the quantity of Coke.
Increase.
Increase. So that would lead to a, what sort of direction are they? Is that a positive or negative relationship between those two things? Positive.
Increase in quantity or increase in quantity in demand?
The quantity demanded. So if we decrease the price of Coke, it leads to an increase or decrease in the quantity of Pepsi. I said Coke this time, didn't I? Decrease in the price of Coke leads to an increase or decrease in the quantity of Pepsi, the demand for Pepsi.
Decrease.
Decrease. Down. One goes down, the other goes down. Positive relationship or negative relationship?
That'd be positive.
That'd be positive. So, peanut butter and jelly. Increase the price of peanut butter leads to an increase or decrease in the demand for jelly. Decrease. They move in opposite directions. A negative relationship. Beer and wine, negative 1.2. Complements or substitutes? Complements. So beer and wine go together according to the data. Maybe not according to you personally. Oh, I'll have wine tonight or I'll have beer. I don't know. I can't decide. So there's substitutes in your mind, but that's not necessarily what's going on in the real world. By the way, this isn't real world data. This is made up data. But this is what an economist would do, would be to do a statistical analysis to see what they are. Because sometimes the results in the market are counterintuitive to your gut. A lot of times they go along with your gut, but sometimes they don't. And so maybe the story would be, oh, we're having a party tonight, it's Friday night, everybody's coming. Well, we better get some beer, and well, there's a lot of different people coming, we better get some wine too, right? So when you go to the liquor store, you buy beer and wine. So maybe drinkers tend to purchase those things together.
Meanwhile, if
Right?
the price of beer goes up, they'll just be like, oh, well, I might as well not drink at all now.
Possibly, but in this particular case, beer prices are down, let's have a party. Well, now we got to buy some wine too, even though wine prices didn't go down. But now that we're going to have a party, because at least beer's cheaper, we're going to buy beer and wine
Put
together.
some of it towards wine.
So the two end up being these complements. Yes?
So I have a question for you. So the text says that a complement is defined by being able to use the same resources of production to replace it. So in other words, if you could make...
That's in production, that's different.
Okay.
So Becky was bringing up a question about the definition for the book about whether you can use the same resources, and right away I knew that we were on the supply side shifter of price of related outputs.
So don't confuse complements in supply with complements in demand.
Correct.
Okay.
So they're on both shifter lists. So the demand curve has this substitute complement deal going on like this. When we're wearing our farmer cap with wheat and corn, I can produce either wheat or I can produce corn. Then we're talking about substitutes in production. So there can be substitutes in production, there can be substitutes in consumption, which is going to lead a nice segue into the next elasticity we're going to get into, which is supply elasticity. But let's wrap up this one here. So let's do the interpretation since it's right here on the board. A 1% increase in what? Let me let you guys start to fill in the blanks rather than you just copy me straight out here. So we always start off this way, by the way, because we always take that number and put it over 1. Our little trick now that we got. A 1% increase in the price of beer leads to a what?
A 1.2% decrease in the quantity of wine.
Good. All right. Decrease in the quantity of wine. Again, all we're doing is we're tracking this little decrease part came from the sign. If that would have been a positive sign, then we would have said the other way. The 1.2, of course, is that part's right here. And the 1% again is right there.
Well, I'm confused now because we reversed what the problem was, which was a decrease in the price of beer.
That's right. Good point. So, did anybody else get tripped up there? That's confusing, isn't it? I kind of messed with you. I'm glad you reminded me that I messed with you because it's just kind of on autopilot. So you guys got to pause me once in a while. Say, reverse, come back. The interpretation of it, the interpretation of the number is different maybe than what was going on in the problem. So I'm layering on a couple different things, by the way. So here we're just taking that number and saying, how would you interpret a negative 1.2? And generically, we can always put a 1% increase. We'll just start the story off that way and then kind of let it play through. And then it always works in reverse too, because this story makes sense now too, right? 10% decrease in beer leads to a 12% increase in wine. So we're just kind of telling it in a different way.
You assume it works the same both directions.
It does work the same both directions, yeah. Okay, good question. Anything else there? Let me put the general here then. So so first of all, let me just put a big sign matters. Maybe some other, sometimes size matters too, but not in this case. The sign matters. All right. So if the cross price elasticity is less than 0, I'll just kind of follow with what we just did here, then the goods are substitutes. The goods are substitutes. I'm not quite getting my board as good as I want. Then my big face gets in the way. This would be good for the review here. If the cross price elasticity is greater than 0, then we've got complements. The goods are complements. Does that look right?
No.
I thought we said the opposite.
Oh, somebody's awake here. So,
Man.
price of Coke goes up, demand for Pepsi goes down. That one is always bizarro, isn't it? You just kind of want to go up with it. Pepsi gets more expensive. We buy more Coke or less.
Buy more Coke.
Or if it's greater than 0, the two are substitutes. Peanut butter and jelly are up here. I just want to highlight how challenging this is. So each time I go through that thought process, you guys should do that on your test too. If you're thinking complements and substitutes, go back to peanut butter and jelly, Coke and Pepsi. Oh yeah, price of Pepsi goes up, I buy more Coke. Positively related. That's why I'm trying to go through that a couple different times. Finally, if it's equal to 0, what do you figure between these two goods? They are unrelated. Good. See, we're catching on. Unrelated. Those two things don't belong with each other. No relationship between each other. All right. Final elasticity is the supply elasticity. The elasticity of supply. And that one is going to look very familiar, except for right here. Of course, we're talking about the supply curve now, so this is the percentage change in the quantity supplied rather than demanded. That's the only difference for a given change in price. Kind of back to the way it was for the elasticity of demand, but now we're looking at the supply curve. All of these formulas, I've been leaving it off. I'm going to put it one more time up here. But we've got the change in the quantity supplied over the average quantity. We got the change in the price over the average price. So notice sometimes a problem might have you work through the percentage change. Other times, the ones we've done today, I just gave you the percentage. Got to be able to go back and forth on that. Okay, so that's all the same. And the properties are going to be similar as well. I just squeezed this on here. This isn't too big a deal. Let's put 2 graphs. In fact, let's put 3 graphs. Let's get crazy. Let's just get wild. Wild and crazy. So here we go. let's put a supply curve that's perfectly horizontal. In the middle, let's put one with some slope to it. And the last one, we'll put the extreme case of it being real vertical, a straight line, perfectly vertical line. Similar to what we did with demand. Which one shows a supply curve that's unresponsive to a price change? Which one shows the last one, right? So we got an unresponsive supply curve. Here's a little trick for you that applies to both supply and demand. I don't think I gave you this little tip of the day yet. As the supply curve starts to get steeper and steeper, like we can even evolutionize this thing. As it starts to get steeper and steeper, it starts to look like an I for inelastic. Great way to remember when things are steeper. Same thing applies for a demand curve. If we take a demand curve that's real steep, it kind of looks like an I for inelastic. So it's relatively inelastic. Same thing applies for the supply curve going on. So that's a perfectly inelastic supply curve. Here we have a perfectly elastic supply. Perfectly elastic. And then in the middle, we've got the regular upward sloping supply curve. Its elasticity is going to change at different points along it, just like we saw with the demand curve. Okay, so to tie in supply elasticities and demand a little bit, I want to think about things that influence the elasticity. You know, why does cocaine look like an I and bananas look like this one or whatever? You know, what causes things to look like that way? So, things that affect the elasticity of demand. And these are very similar to the things that affect the elasticity of supply as well. Number one that I want you to keep first and foremost is the availability of substitutes. The availability of substitutes. The more subs we have for a good, the more substitutes. So imagine fast food hamburgers, or imagine something else. We can think about cell phones. We can think about anything, whatever good we want to define. If there's more and more substitutes available, what happens to the elasticity of demand? If we're to look at the demand curve, would that make the demand curve steeper or flatter with more substitutes? Lots of substitutes available. Flatter?
Say flatter, because you have more options.
You got more options, that's right. So think about that if McDonald's raises their price of hamburgers too much, I'm going to Burger King. Boom, they're going to lose my business. Right? So we got more responsiveness on
So in that
the
example,
quantity demanded.
that example you just did, the quantity measured is McDonald's burgers, not all burgers.
That's right, that's right. And that's going to bring up my one of my next ones here. So the more elastic the demand is, which in this case is, you can associate the way we've been doing it, it's flatter, more elastic. Now, part of this one that Rachel was touching on is how we define the good. So let's put a little extra note here. May depend on how the good is defined. Example, I'll just play right off of Rachel's thing here. McDonald's hamburger versus, yeah, all fast food. Let's call them even fast food hamburgers. McDonald's hamburger versus fast food hamburgers in general. Which one has a more elastic demand?
Probably McDonald's.
The McDonald's
No, in general.
or the other one?
In general.
So now go back to this definition. Which one has more substitutes available? The McDonald's hamburger or a fast food hamburger in general? Which one has more substitutes available?
McDonald's.
McDonald's.
So I was right.
Because
Right? Why?
I'll give you a gold star after that.
One of your substitutes for going out is a bean burrito at Taco Bell, right? Some days you're like that, right? I could go for a bean burrito or McDonald's, I don't know, right? So the bean burrito is still a substitute for either a fast food hamburger or a McDonald's hamburger. So as we more narrowly define the good and we go to the McDonald's hamburger, the substitutes available are Burger King, Wendy's, etc., and Taco Bell bean burrito and blah, 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 the pizza joints. So there's more substitutes available for the McDonald's hamburger because it was more narrowly defined. So the key here is that the more narrowly we define a good, the more elastic demand will be.
So would that mean like highly specialized items would have more?
It depends on the item. In general, that might be the case, but maybe a specialized item, it's a one of a kind. Like there's no really good substitutes. So always go back to the substitute definition to think about that. All right, number 2, the fraction of income spent on good. Which one are you more responsive to? A 20% increase in the price of a pack of gum or a 20% increase in the price of an iPod?
Oh.
Which one do you change your behavior more quickly on? Which one are you more responsive to? The iPod, the more expensive item, right? So number 2 is the fraction of income spent. The fraction of income spent. The fraction of income spent on the good. So the larger the fraction, the more elastic the demand curve will be. Because it's a big deal to you. So example, pack of gum versus an iPod. iPod's running whatever, $400 to $600. Well, they're not up to $600, maybe $400 to $500. Pack of gum is $1. You go to the store and you're like, oh, they raised the price to $1.20. Who gives a rip? What's another 20 cents? Right? So you're unresponsive. So you're more unresponsive with a 20% change. I'm using just kind of just to put a little meat on the bones. Versus your $400, $500 iPod going up by 20%, that's a big deal. Okay, let me get through this last one here. Time. Time for adjustment. If we give you more time, so if we, instead of how are you going to react today, we say how are you going to react in a month, or how are you going to react in a year. If we give you more time to adjust your behavior, is that going to lead to a more elastic demand or a less elastic?
I'm going to go with less elastic.
Less? Lawyer's saying no more.
Define behavior.
So the amount of purchases you're going to make and how you're going to react to the price change. So if the price change goes up by 20%, but now we look at the demand curve for the week versus the demand curve for a month. And maybe gum is the wrong thing to do, but maybe iPods or something else. If we allow you more time, what do you do if you've got plenty of time and you're facing an increase in price, a substantial increase in price? What are you going to search for?
A substitute.
Substitute. So it ties back into this one a bit. The more time we allow you to search for substitutes, the more you're going to do that. So more time leads to a more elastic demand.
Would there also be some elements of just adjusting to that's the norm for that price now, so you're more willing to accept a higher percentage?
Maybe that's getting a little deeper. I'll chat with you a little bit more on it. Okay, let's call it a day there. Come on up if you have any questions. I emailed a couple of you. If you have not gotten a 70%, come up and see me. We need to talk. I sent you an email. All right, so what are you saying?
I wonder if we don't become used to the higher prices, if they give them more time.
To just pay it?
I
I think the other attributes of the good would probably